Hello, myself Mohammad Mansoori. Today's video about my term project DA378. I am doing a bachelor's honors in data science and AI from IIT Guwahati. This project is about predictive maintenance using machine learning to anticipate industrial equipment and failure. Okay. So in industry, unexpected machine failure cause significant financial loss and safety risk in manufacturing. The accuracy of an trap. So in industry, most of the time the failure data is very less. So if we just follow the accuracy, it's become a trap because we are identifying the failure. The core question we will try to answer by this project, that can we develop a system that flags a high risk machine cycle before its catastrophic breakdown occurs. Tools and technology I use. So I use Python as a language, and the VS Code as an environment to perform the coding. And Panda and NumPy for data manipulation, visualization, Matplotlib, Seaborn, and for machine learning and the performance optimization, I use scikit-learn. For dataset overview, I took a dataset Kaggle Hub, and is a UCI machine learning repository. The AI for I 2020, that is the dataset name what I use from Kaggle. It has a 10,000 records with multiple key features like process, air, temperature, rotation speed, torque, and tool wear. And data is it's like that, it has a multiple column including all the features related to sensors related to the tool overview. So let's go to my data, my code. So here I am pulling all the necessary libraries which I mentioned earlier. Then here I am loading the data from the Kaggle, and here I am doing some exploratory analysis, what kind of data is, and and what are the types of data, objects or float or integer, just to understand what kind of data it is. And also I'm counting how many normal failure in the machine failure column, how many are in normal and how many are in the failure condition. Let's go to the data exploratory data analysis codes. So where I'm doing the same exercise just to find it out, what are the uh, how many are in the normal and how many are in fail. So as you can see, it is totally imbalanced data. Only 3.4% of the data has a failure information. Also I plotted few what type of machine, but even that is also very low. It is max is 3.9 from the L machine type. Okay. So here I'm analyzing the all the sensor data by in the histogram, where all comparing all of them in terms of failure. The orange indicates the failure. So as you can see, torque and tool wear is similar. Here I am doing histogram, that how this each parameter or each feature are associated with and correlated with each other. So this allow me to which feature I can drop, or which feature are more significant. As you can see, the torque is more significant impact on the machine failure. This is the same thing I'm printing here just to find it out which feature are directly associated or most impactful associated with the machine failure. So as we can see, these are the two features. Just the data cleaning part, as data is mostly clean as it is a synthetic data, so we are not doing much data cleaning part. In the feature engineering, create a new feature. So I created two new features: data power and temperature delta K. And then I'm just finding out the values of it. Let's go to the Train and split, I did train and split 60% of train data, 20% of validation data, and 20% of final testing. Model training, I use, as I mentioned, I use the random classifier as a model. So I run a two model initially. One is a normal model without any giving any parameter. Second is I given a class weight as a balance in the parameter. And here we are evaluating how it's look like. So when without parameter, its recall is 0.75, accuracy is 91. This one is 68, while threshold is balance is 0.05. But somehow this is still low as per industrial standard. So now I put the confusion matrix, same information there. Now I am doing a threshold to find out the best value for the balance. So I just run a loop from 0.005 to 0.70 to find it out the best one. So for the best, we got the result is 0.82, and further you will see it, we got 0.92 in that. So now I am pending, and finally we got in the 0.05, we got confusion matrix of the recall is 0.91. This is a very good batch. This is a very good performance what we got. Other I did feature importance, means I run some feature importance using scikit-learn. So either I got the torque and power is a most important features of this data set, which directly impacted the failures of the equipment. In the result summary, these are the result summary which I am plotting each and every models what I run. So conclusion everything, I'll go back to my PPT again. So concluded in the project wrap up, we successfully built the prediction system that transfer the raw data sensor data into the actionable maintenance alerts, achieve a 91% of failure detection rate, even though data was completely imbalanced. Through the specialized threshold tuning, we found out the 91% of the failure detection. Key away is that always in the real world, accuracy is often a trap. So if we just follow on the accuracy, we may lose a actual business case. Here the business case was to find it out the failure, so recall was most important. So this is what I mentioned here. Scalability, the current pipeline is built to be a model agnostic, meaning it could be easily extended to incorporate deep learning or real-time streaming data or live factory IoT analysis. So in the for future work, we can apply the a few more exhibit or other model to find or fine tune. And also we can run, as I mentioned here, we can do some deep learning here to find out the more details about this data, and to fine tune and to get the more better model. So this was all about my project. Thank you very much.